Hello guys, welcome to my video on the introduction to probability. This video playlist will focus on chapter 10 section 1, which is basic concepts of probability. Before I get into the lecture itself, I want to state that probability is the foundation to statistics. To understand statistics as a whole, we first must be comfortable with probability. I should say. So, what is probability? Probability, in the simplest definition, is the something occurring. In short, probability of something occurring is a number that represents how likely it is to occur. You can think of it as a percent chance of something happening. We use probability every day to predict the likelihood of something happening or something not happening. For this class, at least, we're going to be using probability experiments. And a probability experiment is a process that leads to well-defined results called outcomes. An outcome is the result of a single trial of a probability experiment. Now, when you're looking at all the outcomes for a probability experiment, we call that a sample space. And the sample space is a set of all possible outcomes of a probability experiment. We can refer to the sample space as the universal set. And an event is any subset of the sample space of a probability experiment. So the sample space is going to be the universal set, and the event is going to be a subset of the sample space. The outcomes can be considered the elements of a set. And the experiment is how we are able to find the three. There are three types of probability, but in this class, we're only going to focus on two. Mainly the first one that I'm going to discuss. The first type of probability is theoretical. The second type is subjective, and the third type is empirical. Before I explain theoretical and empirical, I want to go over subjective briefly. Subjective is more opinion-based, as having a educated guess. For example, when a meteorologist says there's a 40% chance of rain, that is using technology to predict the likelihood of it's going to rain. That is subjective because it's going based on opinions, it's going based on what is being seen in the pattern of the weather. Also, when we predict things such as the score in an exam or how many you got correct, that is subjective because that is more opinion based. When it comes to theoretical probability, we use that branch of probability to determine the likelihood of events without actually performing the event. For example, when you roll a dice or a die is a single dice, and I ask you what's the probability of you getting the number 2 when you roll that die. There is a 1 in 6 chance of you having the number 2. You know that without actually rolling the die because you're going based on how many sides the die has, and then determining how many will give you the number 2. And when it comes to empirical probability, that is based on research, data that you're collecting into a frequency table. And that is going to be based on what you're observing divided by the number of trials that you have conducted or the total of your sample size. To find the probability of an event using the theoretical probability formula, we're going to use this formula down here. The probability of an event, P of E, equals to N of E, which is the total outcomes for the event, divided by N of S, which is the total of the sample space. I want you guys to get comfortable with this notation right here. And this is the definition for simple probability. Simple theoretical probability. Empirical probability, to find that, is going to equal to the observed frequency for a specific event divided by the total number of trials, and we can call that the total frequency. So once again, this is just an introduction to what is probability. And remember, probability is the likelihood of an event occurring. So in this video, we're going to answer questions 1, questions 2, and questions 3. It says here for question number 1, when you flip a coin, what's the percent chance that it'll land heads up? What is the probability? When you flip a coin, there are two sides, heads and tails. So there's a 50% chance of the coin landing on heads, and there's a 50% chance of the coin landing on tails. So it says, what is the percent chance that it will land heads up? There is a 50% chance the coin will land heads up. And it says, what's the probability the coin will land on heads? Well, the probability the coin will land on heads using probability notation will be 50%. The probability can be a percentage. We can write 50% also as a decimal by dropping the percent sign and moving the decimal 2 places to the left. So the probability of the coin landing heads up is going to equal to 0.50, or some people can say 0.5. When we convert that percent into a decimal, it can be written as 0.50 or 0.5. And you can represent your probability in another way, which is as a fraction. There's a 50% chance of the coin landing heads up, which means half of the time it will land on heads, half of the time it will land on tails. So the probability that the coin will land heads up can also be written as 1/2. As you can see, you can write your probability in 3 different ways. You can write it as a percentage, as a decimal, or as a fraction. These are all equal to each other. So that is the probability the coin will land on heads. We're now going to do another example, and we're going to look at question number 2. It says here, a bag with 6 marbles is shown below. 3 marbles are blue, 1 is red, 2 are yellow. A marble is chosen from the bag at random. What is the probability that it is blue? Write your answer as a fraction or as a whole number. Now, I want to find the probability of a blue marble, and I'm going to use the theoretical probability formula. To find the probability of a blue marble, it's going to equal to the total number of blue marbles in my bag divided by the total number of marbles in my bag. The sample space is the marbles. And that is my sample space, which is also my universal set, if you want to look at it like that. And the event is focusing on blue marbles specifically. Now they look kind of green, but blue marbles, circle it with a different color. Looking at the picture and also in the direction, there are 3 blue marbles in my bag out of 6 total marbles in my bag. So the probability of me having a blue marble is 3 out of 6. Remember, you must reduce this fraction after you find the probability. Both 3 and 6 are divisible by 2. So I'm dividing 3 from the top and 3 from the bottom. 3 divided by 3 is 1. 6 divided by 3 is 2, which is 1/2. Now for Alex, the answer of 3/6 will be acceptable. But on an exam and in class, the reduced answer is preferred. Let's do another one. It says, a single die is rolled. For 3 events listed below, compute each probability. Now, before I continue, I first want to know the sample space that I have when I roll a single fair die. So, capital S for sample space. And remember, a die is a cube with 6 sides on it. And there are dots painted on each side to represent the number. So number 1 here, 2, 3, so on and so forth. There are 6 sides to a cube, to a die. So therefore, my sample space will be the number 1, 2, 3, 4, 5, and 6. Now, there are 6 possibilities right here. 6 outcomes in my sample space. Out of the 6 outcomes in my sample space, I want to find the probability of having the number 5. Out of 6 outcomes, there is only one option that gives me the number 5. Therefore, the probability of me selecting the number 5 when I roll a single die is going to be 1/6. Now, I want to look for a number less than 5. To find the probability the number is less than 5, out of 6 options, I want to identify all the numbers that are less than 5. And if I look here, the numbers 1, 2, 3, and 4. These 4 numbers are less than 5. So the probability of less than 5 is 4/6. I can reduce that fraction 4/6 by dividing the numerator and denominator by 2, which is going to give me 2/3. And once again, you can enter in 4/6 on Alex and get the correct answer, but on an exam and in class, the reduced fraction will be the final answer. And the last question says the probability of an odd number. Out of 6 options, how many are odd? 1 is an odd number, 3 is an odd number, and 5 is an odd number. That is going to be 3 options out of 6. So the probability of me having an odd number is 3 out of 6. And I can reduce 3 out of 6 by dividing the numerator and denominator by 3 to give me 1/2. All right, guys. Hope that made sense. Hope you guys understand simple probability on its face value. I'll see you guys in the next video. Take care.